All right, so 7.5, we are going to solve for x. So our whole goal is to get x by itself. But we have a radical. So the basic principle that we're going to follow when trying to get rid of a radical, okay, we'll have problems set up like this. To get rid of the index, which would get rid of the whole radical, we will multiply it, raise it to whatever the index is. So like here. So the index was n, so we're going to raise it to the exponent n, both sides, and it makes it cancel out the radical, and we're just left with x by itself. Okay, so whatever the index is, you're raising it to that power. That's the basics of what we're doing. All right, just a reminder, when it says solve, that means we're trying to find what x equals. That's a question mark. Looks a little dinky, but it's a question mark. All right, so we're going to follow the same steps as we usually do in that we want to move stuff away from x. So what is farthest from x that we can move? To the other side. 2. All right, so it's being added, so we will subtract it. All right, so we get square root of 3x minus 2 equals 4. All right. Yep, the index was a 2, so we're going to square both sides. So on the left side, we just have the radicand. We just have 3x minus 2, and it equals 16, because 4 squared is 16. Now you have this, right? You can do this. Add 2. So 3x equals 18. Divide by 3. X equals 6. All right, let's just check it real fast to make sure we did everything right. Okay, so if we plug that 6 in for x, it'd be 2 plus, I'm plugging it back into the original. 3 times 6 minus 2, and it's supposed to equal 6. Well, what's 3 times 6? 18. What's 18 minus 2? 16. Okay, so square root of 16 is 4. 2 plus 4 is 6. So that works. We did it right. We didn't mess up. Yay. Any questions there? All right, so of course we're going to get a little more complicated when we have not just an index, but we also have an exponent. Basically, we've got a rational exponent. Like here, it's 2/3. Okay, so when that happens, we can get rid of that by multiplying it by its reciprocal, which is the blank. Reciprocal. All right, that's not too complicated. We'd multiply it by its reciprocal. But the issue is what happens is we have to put whatever is left, the x, inside absolute value. Okay, because when we take away that exponent, we don't know whether now it may be positive, it may be negative, whatever. We have to put it in absolute value. Okay, so do not forget that. Okay, so on the problems in your book, it's probably like 8, 10, and 12. You're going to have to use absolute value. Okay, so don't forget about that. Before we try to get rid of that exponent, we need to get the x and whatever's with the x and its exponent by itself. Okay, so that's first. So what does that mean we need to move? What over here? The 2, right? This 2 needs to move, so how should we move it? Divide everything by 2. So these cancel. So we have x minus 2 to the 2/3 equals 25. Okay, so now the whole x parenthesis thing is by itself. So to get rid of 2/3, we're going to multiply it by its reciprocal, 3/2, which we have to do the same thing to the other side. All right, those cancel out. When that happens, replace those parentheses with absolute value. So we have absolute value of x minus 2 equals, let's see, what is that thing as a radical? 25 is on the inside. What's my index? Go ahead and deal with it like this. What's square root of 25? 5. What's 5 cubed? 125. That was just the way I wanted to deal with it. You could have put it in the calculator, but this is your index and this is your exponent. Alright, so you could have put 25 raised to the 3/2 in the calculator and it would have spat out 125, but we did it without. Okay, so now this is what we have left. Absolute value of x minus 2 equals 125. X minus 2 equals 125. Yeah, so what we have to do to make the absolute value go away is we're going to say x minus 2 equals positive 125 or x minus 2 equals negative 125. Okay, that's to account for the absolute value. Because we don't know if what was inside equaled a positive number or if what was inside equaled a negative number. So we're going to have an option of both. All right, now add 2 for both the problems and we'll get our answers. X equals 127 and x equals negative 123. Alright, and you can go back and check both of those for this problem. You'll end up figuring out that they both work. You want to trust me on that one? Okay, you can always just plug it in with the calculator. So you would go back and type 2 parentheses 127 minus 2 and then raise that to the 2/3. Press enter and it should give you 50. And the same thing when you plug in negative 123. Okay, any questions on the front? All right, for the back, which are the last 6 problems on your homework, starting with that number 16, you have to check your answers because the way the problems are set up, they might give you extraneous answers. Remember, extraneous, it's extra, false answers, okay? So it'll give you something that isn't actually a true answer. So you have to double check them. When you do that, check all the possible solutions in the original equation. Okay, not one that you got halfway through the problem, but the original equation. What causes there to be extra answers is when, it's when you raise both sides of the equation to a power. All right. So let's deal with this first one. We actually have an x on each side. What's complicated about this problem is the square root. So let's try to get rid of it. So let's move this first. So subtract 5. Yep, and then we'll square both sides. So subtract 5, subtract 5. So I have square root of x minus 3 equals x minus 5. So as Levi said, to get rid of the square root, we're going to square both sides. The right side, make sure and put it in parentheses because you're squaring the entire thing. All right, so left side, it's just radicand left, x minus 3. Right side, we got some work to do because we need to FOIL that because x minus 5 times x minus 5. Remember, you cannot distribute into a binomial. An exponent. You can't distribute an exponent into a binomial, which so many people want to do. All right, so when you FOIL here, we get x minus 3 equals, let's see, what do we get? X squared minus 5x, which makes negative 10x plus 25. Okay. Right, and I want it all on one side, so I'm actually going to subtract x and add 3 to both sides. So I'm going to end up with 0 equals x squared minus 11x plus 27. And we have a quadratic. All of a sudden, we went from a radical to a quadratic, so we're doing good. 28. Ah, I'm wrong. 28. Sorry. Thank you for catching that. All right. So here we have different options of what we can do. We can put it in quadratic formula. We can complete the square, which all of you have blocked out of your mind, even though you have to use it next year. We could factor. And you could even try graphing and see where it crosses the x-axis. So what do you want to do?
Do the x.
Yeah, the factoring, I think that's fastest, quickest. All right. Well, least prone to mistakes. Because graphing is pretty easy if you type it in right, but sometimes we mess up. Okay, so a times c goes in the top. So that's 1 times 28, which is just 28. And b goes in the bottom. So what multiplies to get 28 adds to get negative 11?
Negative 7, negative 4.
Very good. Negative 7, negative 4. Now you put those in the top of a fraction over a. What was a? 1. Okay? Can't reduce those any. So our factors are x minus 7 and x minus 4. So what are my two different values for x? Positive 7 and positive 4. We get that by saying x minus 7 equals 0. Move the 7 over, and x minus 4 equals 0. Move the 4 over. All right, we got to check them though, because there's high probability that at least one of them is incorrect. All right, so plug them into the original. So I'll have 7 minus 3 in the square root plus 5 equals 7. Well, what's 7 minus 3? 4. What's the square root of 4? 2 plus 5 does in fact equal 7. Okay, so we know that one works. Let's try the other one. This one will be square root of 4 minus 3 plus 5 should equal 4. 4 minus 3 is square root of 1. That's 1 plus 5. That does not equal 4. So that one is not an answer. Just x equals 7 is your answer. For what?
For x.
No, we got the one. There's only one. Okay, any questions there? No? No. If an equation contains two radical expressions or two terms with rational exponents, like down below, got one thing here with a decimal exponent, one thing here with decimal exponent. If that happens, focus on one of them. Okay, so isolate one of the radicals or terms with rational exponents. All right, so we want to get one of these things by itself. Let's go ahead and change those decimals to fractions. What's 0.5? 1/2. What's 0.25? 1/4. There were lots of people on the test that thought 1/4 or 0.75 was 1/4. I don't know how that happened. Quarters. Think of quarters. 75 cents is 3/4. Okay. Anyways, so we need to get one of these things by itself. So let's add 3x plus 4 to the fourth to the other side. And then we'll figure out where we need to go from there. So I'm going to have 2x plus 1 to the 1/2, and that will equal 3x plus 4 to the 1/4. All right. We need to figure out which one of these we want to get rid of its exponent. Okay, what would we, to get rid of this one, what would we multiply by?
2.
2. Okay, so it would make that one go away, but what would happen here? 1/4 times 2,
Be 8.
it'd be 2 over 4, which is 1/2. So that one wouldn't go away or really become any more simple. We'd still have a fraction. Okay, what if we multiply this one? We'd multiply it by 4. Okay, so that one would go away. What's 1/2 times 4? Or 1/2 of 4? 2. Okay, so then we wouldn't have any fractions left, right? So that's what I want to do. I'm going to say this one multiplied by 4 over 1, and this one multiplied by 4 over 1. The left one goes away, so it's just 3x plus 4. And the right one, you said the exponent becomes a 2, so we get 2x plus 1 squared. We're doing good.
So then we have it to 4.
Gotta FOIL it. You are correct. So that's actually 2x plus 1 times 2x plus 1. And it equals 3x plus 4. Alright, 4x squared, very good. Plus 2x plus 2x plus 1. First, outside, inside, last.
So
Let's get it all on one side. So I'm going to subtract 3x and subtract 4. Let's see what we get here. 4x squared. Okay, 2x plus 2x minus 3x. It's 4 minus 3, so just an x. And then minus 3 equals 0. Woo-wee! You want to do factoring again, or do you want to do one of the other ones?
Which one's the easiest?
Do the x again. I think that one's easiest, but I would say graphing would be the other kind of easy option. Okay, I'm going to bring it up here. All right, so this one, a times c gives you negative 12. B is 1. So what numbers do we plug in there? Those don't add to get 1. Those are options, though. What else multiplies to get 12?
4 and 3.
4 and 3. Those I think could give us a 1. Which one needs to be positive? 4 is positive, 3 is negative. That way when you add them, it gives you a positive 1. Okay, so now that gives me negative 3 over, what was a? 4. And 4 over 4. That one reduces. Woo! To 1 over 1. All right. I'm going to put my x's in the denominator so I kind of have a clue of where to go. 4x minus 3 and x plus 1 equals 0.
Why we put them over 4?
Because you always put them over a, and right here, the a is a 4. Good question. Okay, so now I have that 4x minus 3 equals 0, and x plus 1 equals 0. X equals negative 1, that one was fine, easy. Add 3. Divide by 4. X equals 3 over 4. All right, got two options, but we got to check them. So you can check these by plugging them in the calculator, or, yeah, by plugging it in the calculator. So, whew. Oh yeah, it's still in here. Okay. 3/4 into the original equation. So I put parentheses 2, parentheses 3/4, plus 1 to its exponent, which is 1/2. And then did the same thing over here with the 3/4 into the second part, the 3x, so 3/4 moving for x plus 4 to 1/4. So when I press enter, it should equal what based on the original equation? 0. Aha! It does. Hooray. Okay? Now, I don't know if y'all knew this or not, but you can make it say whatever you just typed in. If you press second enter, it puts in whatever you wanted, whatever you said. So I'm going to replace my 3/4 with -1. -1. And then delete that. Okay. And do the same thing down here. -1. Sorry, it's hard to see. Okay. So let's see if it equals 0. Aha, it says non-real answer. That happened because if you would have done it by hand, the first thing that you had to take the square root of ended up being -1. And you can't take the square root of -1 and get a real number. We can get imaginary, we're not wanting that. So, 3/4 worked, -1 did not work. So you can use the calculator like this, but you can't mistype things because that messes it up. So you can always do it by hand. So this one did not work and this one did. So there's your answer.